Hi everyone, welcome back to our channel. In the last video, we have discussed on the section revisiting irrational numbers and examples related to it. If you have not watched it yet, please do watch and do comment if you have any doubts. In this video, we will be discussing the exercise problems, exercise 1.2. So without any delay, let's get into the video. Question number 1. Prove that root 5 is irrational. So this proof is based on the technique called proof by contradiction. So let us assume to the contrary that root 5 is a rational number. So we can write it in the form P by Q, where P and Q are integers and Q not equal to 0. Integers and Q not equal to 0. So what is a rational number? A rational number is a number which can be represented in the form P by Q, where P and Q are integers and Q not equal to 0. So root 5 can be written in the form P by Q. Suppose P and Q have some common factors other than 1. P and Q have common factors other than 1. Then we divide both P and Q by the common factor to get co-prime integers. So co-prime integers are those which have only 1 as their common factor. Co-prime integers A and B. Now root 5 can be written as A by B. Now let's take B to the other side. Rearranging, we get B root 5 is equal to A. Now squaring both sides will give you B root 5 the whole square equal to A square. So we can write 5B square is equal to A square, since root 5 the whole square is equal to 5. We can write 5B square is equal to A square. Let this equation be equation number 1. Now we can say B square is equal to A square divided by 5, which means 5 divides A square. So by theorem, we know that if 5 divides A square, then 5 divides A as well. So you can write A equal to 5 into C for some integer C. As we know, 5 divides A square. Then we can say 5 divides A by theorem, which we have already explained in the last video. If you have any doubt, please go and check that video. So we can write A as a factor of 5. Now we can substitute this value of A, substitute A equal to 5C in equation 1. We get 5B square is equal to 5C the whole square. So 5B square is equal to 25C square. B square is equal to 5C square and C square is equal to B square divided by 5. As 5 is multiplication on the right hand side. When it goes to the left hand side, multiplication becomes division. So 5 was in the numerator. When it goes to the LHS, it becomes a denominator. So we can write 5 divides b square. Then by theorem, we can say if 5 divides b square, then 5 divides b. Therefore, A and B have at least 5 as a common factor, which contradicts the fact that A and B are co-primes. Co-primes means it should have only one common factor, that is 1. But here we can understand that both A and B has another factor, that is 5. So this contradiction has arisen because of our incorrect assumption. That root 5 is rational. Therefore, we can conclude that root 5 is irrational. Hence, proved. Hope you understood this problem. Let's move on to the second problem. Question number 2. Prove that 3 plus 2 root 5 is irrational. So we are proving this with the technique proof by contradiction. So let us assume to the contrary that 3 plus 2 root 5 is a rational number. So we can write it in the form of P by Q, where P and Q are integers and Q is not equal to 0. Suppose P and Q are co-prime, that is, they have only one common factor, that is 1. Suppose P and Q are co-prime such that 3 plus 2 root 5 is equal to P by Q. If P and Q have any other factors other than 1, then we can divide both P and Q with that common factor and make it co-prime. Okay. So now we can write 3 plus 2 root 5 is equal to P by Q. Rearranging, we get 2 root 5 is equal to P by Q minus 3 and root 5 is equal to P by Q minus 3 divided by 2. So this can be written as P minus 3Q by Q divided by 2, which is equal to P minus 3Q by Q into 1 by 2, which is equal to P minus 3Q by 2Q. Since 3, 2, P and Q are integers, we can say P minus 3Q by 2Q is a rational number, which means since P minus 3Q by 2Q is rational, then root 5 is also a rational number. But this contradicts the fact that root 5 is an irrational number. We have already seen that in the first question. So we can conclude that 3 plus 2 root 5 is irrational. Hence proved. I hope you understood this problem. If you have any doubt, please do comment so that I can explain. Let's move on to the next problem. Question number 3. Prove that the following are irrational. So first question, 1 by root 2. So we are proving this by the technique called proof by contradiction. So let us assume to the contrary that 1 by root 2 is a rational number. So we can write it in the form P by Q, where P and Q are integers and Q not equal to 0 since it is a rational number. So we can write 1 by root 2 is equal to P by Q. Suppose P and Q have common factors other than 1, then we divide both P and Q by the common factors to get the integers A and B such that they are co-primes. So we can write 1 by root 2 is equal to A by B. So squaring on both sides we get 1 by 2 is equal to A square by B square, and rearranging we get B square is equal to 2A square, and A square again by rearranging we get A square is equal to B square by 2, which means 2 divides B square. So by theorem, if 2 divides B square, then 2 divides B as well by theorem. So we can write B equal to 2C since B is a factor of 2 for some integer C. Now let's substitute B is equal to 2C in the equation. B square is equal to 2A square, that is 4C square is equal to 2A square. That is, we are substituting B is equal to 2C. So that is 2C the whole square is equal to 2A square, which can be written as 4C square is equal to 2A square. Again we take 2 to the other side. We get 4C square divided by 2, which is equal to 2C square. So we write A square is equal to 2C square. Now keeping C square here, taking 2 to the other side, it becomes A square by 2, which means we can write 2 divides A square. So by theorem, if 2 divides A square, 2 divides A as well by theorem. So from this we can understand that both A and B have at least 2 as their common factor, which contradicts the fact that A and B are co-primes. Co-primes means they should only have one common factor, that is 1. So this contradiction has arisen due to our incorrect assumption that 1 by root 2 is rational number. So this contradiction has arisen due to our incorrect assumption that 1 by root 2 is a rational number. Therefore, we can conclude 1 by root 2 is irrational. Hence, proved. Question number 2, 7 root 5. So we are proving this with the help of proof by contradiction technique. So let us assume to the contrary that 7 root 5 is a rational number. That is, we can write it in the form A by B, where A and B are integers and B not equal to 0. Suppose A and B have common factors other than 1, then we divide both A and B by their common factors to make them co-primes. So we can write 7 root 5 is equal to A by B. Rearranging we get root 5 is equal to A by 7p. Since 7 was in the numerator, if we take it to the RHS, it becomes the denominator. So A by 7b. Since A, 7 and B are integers, we can say A by 7b is a rational number. So root 5 will also be a rational number. But this contradicts the fact that root 5 is irrational. So in the first question we have already proved that root 5 is irrational. So the assumption, our assumption that 7 root 5 is a rational number is incorrect, and we can conclude that 7 root 5 is irrational number, hence proved. I hope you understood this problem. Let's move on to the third one. Third question, 6 plus root 2. All these problems are solved in the same manner. So let us assume to the contrary that 6 plus root 2 is a rational number. That is, we can write it in the form a by b, where a and b are integers and b not equal to 0. Suppose a and b have common factors other than 1, then we divide both a and b by their common factors to make them co-primes. So 6 plus root 2 can be written in the form a by b. So by rearranging, we can keep root 2 in the LHS and take the rest to the RHS. So a by b minus 6, which can be written as a minus 6b by b. Since our a, b and 6 are integers, we can say a minus 6b by b is a rational number, which means root 2 is also a rational number. But this contradicts the fact that root 2 is irrational. We have already studied the theorem where we have proved that root 2 is irrational. So this contradiction has arisen because of our incorrect assumption that 6 plus root 2 is a rational number. Hence, we can conclude that 6 plus root 2 is irrational. Hence, proved. So if you get any questions to prove the irrationality, the steps that you have to follow is the same. Hope you understood all the exercise problems. So that's all for today's video. Hope you understood the concepts. If you have any doubts, please do ask your queries on the comment section. Thank you.